All right, let's talk about one of the most common questions you're going to get in any engineering or project management interview. How do you handle unexpected problems on site? The key to absolutely acing that answer comes down to 3 letters, FCR. That's the field change request. If you can master this process, you're going to seriously impress your interviewer. So today, we're breaking it all down.
So picture this. You're out on the construction site, things are humming along, and then, bam, a clash. A pipe is heading straight for an electrical tray that, whoops, wasn't on the original drawings. So what do? This isn't just some textbook question. This happens all the time, and how you answer it can literally make or break your interview.
Here's our game plan. First, we're going to define what a field change actually is, and just as important, when you really need one. Then, we'll walk through the official step-by-step approval workflow and cover the exact documents you need to pull together. And to wrap it all up, we'll dive into a real-world case study, complete with the calculations you'd have to do.
All right, let's start at the beginning with the core concept. Any great interview answer starts with a really sharp, accurate definition. So let's nail this down.
So a field change request, or FCR, is the official, formal way you deal with the unexpected. This isn't just a quick email or a chat with the foreman. Nope, it's a structured, documented request to change the official construction drawings. We call those the IFCs because something in the real world doesn't match the plan. Think of it as your formal problem-solving toolkit.
Here's a super simple way to think about it. You only need an FCR when 2 things are true. 1, you've found a conflict, and 2, that conflict actually impacts the approved design. You know, if it's a tiny adjustment that doesn't change what the design is trying to do, you might be okay. But the second you have to change the design itself, an FCR is absolutely non-negotiable. Quick pro tip, if you're ever in doubt, just start the paperwork. It is so much better to have it and not need it than the other way around.
Okay, so we know what it is. Now let's get into when you need to kick one off. Your interviewer is going to want to see that you can spot the common situations that scream, we need an FCR.
These are the usual suspects, right? You might find a clash between trades, like HVAC ducts and plumbing pipes wanting the same exact spot. Or you might dig and hit an old foundation that wasn't on any record. Sometimes you realize the design doesn't quite meet a specific Saudi building code or an NFPA fire safety rule. Or hey, maybe the material you were supposed to use just isn't available anymore. And of course, a big one is when a safety issue forces a redesign, or when the client themselves ask for a change. Knowing these shows you get what it's really like on a project.
Seeing the problem is just the first step. The next, crucial part is knowing how to navigate the approval workflow. An interviewer doesn't just want a problem spotter. They want a problem solver who knows the official process.
The workflow is a really clear 5-step process. First, someone on site identifies the issue. Second, the contractor puts together and formally submits the FCR with all the backup documents. This is where you do the heavy lifting. Third, the project consultant reviews it, and they're laser-focused on making sure it complies with codes like SBC and NFPA. Fourth, if it's all good, the original designer updates the drawings. And finally, number 5, the client gives that final green light. Every step is a quality gate to make sure things are done right.
You have to remember, a request is only as strong as the evidence you provide. Submitting an FCR isn't just about saying, hey, there's a problem. It's about proving why your proposed solution is the best one. And that takes a professional and, most importantly, a complete documentation package.
A solid FCR package has a few essential pieces. You'll need a marked-up drawing showing the before and the proposed after. A crystal-clear screenshot of the clash, maybe from Revit or Navisworks, is a must. You've got to summarize how this change impacts materials and costs. And this is critical. You have to include your revised technical calculations and that formal compliance review. Honestly, the number one mistake people make is submitting an incomplete package. That's the fastest way to get your FCR rejected and cause major delays. This isn't just paperwork, you guys. It's your case file.
And this right here, this level of detail is what separates the pros from the amateurs. Your compliance review can't just be a generic, yep, it's fine. It has to point to specific codes. So for example, a plumbing change might need a check against SBC 501. A sprinkler modification, you'd better be referencing NFPA 13. Being able to name these specific standards in an interview shows a much, much deeper level of understanding.
Okay, theory is great, but interviewers want to see that you can actually apply it. So let's walk through a super common real-world scenario to connect all these dots.
Here's the situation. We've got a 65mm chilled water pipe, and it's on a direct collision course with an electrical cable tray that wasn't in the original plans. The solution seems obvious, right? Just reroute the pipe. But the correct way to do that is to document and get it approved through a formal FCR.
So the very first thing you have to do is quantify the impact. What's this going to cost us in materials? The new pipe length is simply the old length plus 2 times the distance you need to offset to get around the tray. It's a simple bit of math, but it's absolutely vital for updating the project's bill of quantities and keeping track of costs. Every change has a ripple effect.
Now for the really crucial engineering check. When you add length and bends to a pipe, you increase friction, which changes the pressure drop in the system. You have to recalculate it. This formula here is a simplified version, but it shows the principle. This step is what proves that your system will still work as designed and that it still complies with codes like SBC 501. You have to prove that your fix didn't just create a brand new problem downstream.
And there's our successful outcome. Because our calculations proved the new pressure drop was well within the acceptable limits set by the NFPA and SBC standards, the FCR gets approved. The drawing is officially revised and construction can move forward, safely and correctly. And that's the whole journey, from problem to a fully documented, approved solution.
So you've got the process down from A to Z, but what happens when the consultant disagrees with your solution or the client pushes back hard on the extra cost? Now that's the next level, isn't it? Thinking about how you would navigate that kind of conflict, well, that's what separates a good answer from a truly great one. We'll leave you with that to think about.